Good day everyone. Today we will explore how to create a basic model using the new modeling user interface for osmosis, also known as MUIO. So basically in the description of this video you will find um, as another repository with this Excel file which contains all the details and data necessary to create this model. Once you have this Excel open and also you have installed the MUIO interface, as you can see here, probably if you are starting in this journey, the unique model that you will have available is this one, the default one known as Clues Demo. Obviously that because of I have been working with the interface in other different exercises. I have more models here, but no worries about that when you start with the interface, okay? So, in also in the read the docs, which is in the description of this video as well, you can find more detailed information about the different parts of the interface, also key information about the mathematical model that is behind this interface, which is basically an outdated version of the osmosis code. And okay, let's start with the exercise. Good. So first of all, we need to create a model. So for doing that, you need to go here on the left side. You have like kind of a bar side. Then you will need to click on configure model. That is the third option. Obviously that you have the first one, that is this home page. After that, you have another tab with all the parameters that is in the model here, depending on what is your purpose. It's also possible to change the default value. So in case that you want to do this, you just need to click here, then you can modify the value. For example, let's say that I want to change this lower limit by, for example, 20, and then you just need to click on that and then save data. I'm not going to do that because obviously this is not the thing that I want to do, but just to let you know that it's completely possible to change the default values. However, please keep in mind that you will need to change this before starting the creation of a new model. Otherwise, if you change this default value after creating the model, this change won't be visible for the model that is already created. Okay, so good. I just want to maybe come back here, then just check the parameters just to see that this lower model, this lower limit, sorry, is still in zero. Good. So coming back to the initial instruction, come here to configure model. Then we will create the initial information. Here is basically the model name that for our case would be dummy. Is kind of the region model, the region name or the model name that we want to provide to this exercise. Then for currency, we will work with USD for this case, so American dollars. Then for the purpose, because it's very basic, we will use one mode of operation only. And then depending on what you want to do, you can also include a model description, but let's just put that is a basic model. Okay, good. So once this is done, you can save the new model. So here is ready. Then just check quickly what we have in the Excel file just to start. Basically this is just an initial information. Then the next step is the reference energy system. So as you can observe here, this is just a basic chain of power supply. So here you have two options of primary resources for natural gas. It's possible to extract it domestically or also to import it. After that, this natural gas is feeding into a natural gas power plant which is producing electricity 001, that for this case is basically electricity after generation. And in the same line we have a solar power plant which is producing electricity, obviously taking advantage of solar resources. And after that, this electricity is transmitting to a transmission and distribution technology which is producing basically electricity 002, that for our case will be the final electricity demand. Then in assumptions, you can see that we will work with a modeling period between 2021 and 2035. The discount rate for this case will be 9%. We will use the same rate for both the overall rate and also the individual rate for the different technologies. And then the monetary unit is going to be USD dollars, US dollars, as I mentioned before. And in terms of the number of time slices, we will use 4 time slices representing 2 seasons, rainy and dry, and then 2 day parts, day and night. Good. Regarding the sets, as I mentioned, just one single region. That is what we can do with initially with MUIO. However, it's also possible to work with multi-regional models, but they will not be indexed by region, but just using also the same different technologies for different regions. We are also preparing a demo exercise to show this in the near future, so please stay tuned for updates in this regard as well. Then modes of operation, just one, as we discussed previously, one emission, that is just carbon dioxide. The 4 time slices, rainy day, rainy night, dry day, dry night, that let's say they are the different combinations between seasons and daytime time breaks. The year split is, sorry, the modeling horizon, once again 2021 2035. We will have 3 commodities as seen in the rest, so natural gas, electricity for generation, and final electricity demand. And then we have natural gas extraction, 5 technologies, starting with natural gas extraction, natural gas importation, the 2 power plants, one for natural gas, other one for solar, and finally one technology representing electricity transmission and distribution. Then we have the different parameters that we will need to add in our model. We will start working on this later. And finally, we have other capability inside MUIO, that is implementing different scenarios to achieve comparison. So basically here it's possible to implement different parameter variations in order to represent different scenarios. So for this exercise we will see how to do this for 2 additional scenarios apart from the baseline one. So one to see how a different natural gas reserves could impact the result, and then how let's say annual emissions limit could impact this model as well. Okay, so let's start with the first part, that is basically including the different sets basically. So we start with the time sets. In this case, the number of years, as I mentioned before, will be from 2021 to 2035, right? So it's automatically done when we move this slide bar. Then for seasons, we will create 2 seasons. So this is more or less kind of intuitive. Here we have add season, so we have season 1, season 2. Here we can put the description that this case would be rainy and then dry. Then it's just 1 day tie, and for the daily time bracket we will need to add one more, and this would be day for the first one and then night for the second one. We also need to create the time slices, so let's remember that basically the number of time slices is the multiplication between seasons, day types, and daily time. So in this case, 2 times 1 times 2 is equal to 4. We will need to add 3 more time slices. Here it's like rainy day, rainy night, dry day, and dry night, right? So rainy, sorry, rainy day, right? Instead, in terms of the descriptions, rainy night, then day, sorry, dry day would be better, dry day, and then dry night, right? So this is basically the representation of um, the different times where you are in the rainy season. For example, you are in the rainy season and you are representing the day part of every day, right? So let's say, for example, in a normal tropical country would be more or less between 6 a.m. and 6 p.m., right? So everything that is inside that period is basically what we are representing here in this split of the year. Then, in spite of, it's not necessary to do the linkage between the different time slice and the corresponding season, daytime, daily time bracket, because this is just used when we are using a storage technology. And for this basic exercise, we will not consider that. Just remember that you need to do this kind of combination, right? So here, for example, rainy day is basically season 1 and daily time 1, so it's there. Then rainy is basically season 1 with daily time number 2. Then dry is season 2 with day is daily time bracket 1. Then dry is once again second season with the second daily time bracket, right? Then please remember to update the model. So here we have included the years and the different time slices. Then moving with commodities, if you remember here in the sets, we have 3 commodities, they are here. So we just need to add those. So it would be 3. So we can do NGS for natural gas, then electricity 001 for electricity after generation. Please let's remember that it's totally possible to pause the video and then just retake any of the previous steps and do the exercise on your side, then restart the video and continue with the next steps, right? So here this is electricity after transmission and distribution, right? Then once again, please remember update model to save the changes. Regarding emissions, this is just CO2, that is basically carbon dioxide. One important thing is that please remind to change this unit from tons to kilotons, because as you will see later, the emission activity ratio, that is basically the rate of number of emissions per unit of fuel consumed, the unit is in kilotons per petajoule, right? So it's important to update this unit. Then once again, outdated technology groups is basically to try to create different classifications for the technology that you're using. We're not going to include this, but imagine that you create a technology group. This is basically, another thing that I need to clarify in this part is basically for visualization purposes, right? So when you group different technologies into different groups, let's say, you can then later in the plotting part, you can like see how the different groups are behaving, right? So it's like, for example, you can see per sector. So let's say what is the production of energy in the power sector versus transport or industry, etc. Right? So it's just most for this kind of objective. Then in technologies, imagine you have here the third one, the third column is technology group. So imagine that you have one option, so you can select it, and for every technology you can do this, so you can like classify the different technologies into different groups. Then here in technologies we have 5 technologies, right? So in this case we will add 4 more, right? And here we will start this kind of at the beginning a little bit, um, let's say you need to do it manually, but um, this is like a systematic process where you can like think about how your model is. So it's more or less interesting to do these steps just to understand how the structure um, is being constructed, right? So here um, we will create 5 technologies, right? So basically extraction of gas, import of gas, the two power plants, and finally transmission and distribution. Good. So basically here now we can add the descriptions. For the sake of the time, I'm not going to do it, but please let's take into account that it's totally possible to just change the description here, right? Then let's say that for primary sources, as they are extraction or importation, the unit of capacity we're going to change it because gigawatts is not kind of very normal here, and also just to show that it's totally possible to work with other units. Like for example, imagine that your energy system is quite small. Probably it doesn't make too much sense to work with gigawatts or petajoules. So in that case, probably it's more reasonable to work with megawatts because probably the fleet is not beyond 1 gigawatt, so probably it's much better to work with megawatts. And also for um, activity, in if you are using megawatts, it's better to work with terajoules instead, right? So you can change this. So for the two primary, I'm going to change the units here, but still I will work with petajoules and gigawatts for the case of power plants and transmission, etc. Right? Then the other important thing here is to link the different technologies to input and output fuels, right? So if we go and check the reference energy systems here, you can see that for the extraction and importation of natural gas, they don't have any input fuel, right? So we can keep those fields empty, and then for the outputs we can see that the outputs in both cases are basically natural gas. So here in the output activity ratio we will select natural gas and as the output, right? And it would be the same for imports here, right? Then for the natural gas power plant, basically the input would be natural gas and the output would be electricity 001 according to this, right? So notice that here the input is basically natural gas and the output is electricity 001. Then for the solar power plant, we don't have any input, and then the output is electricity 001. And then for transmission, is the input is electricity 001 and the output would be electricity 002, right? According to our reference energy system once again. Then the other thing important is when we are considering the natural power plant, notice that here we are consuming or we are burning natural gas, so it is going to create CO2 emissions. So here we need to select that the emission activity ratio is going to be activated for CO2, right? Regarding input to new capacity and then input to total capacity, they are kind of ratios that you can use to represent, let's say, resources that are consumed, but they are not dependent on the activity of the technology, but they are going to be depending on the capacity installed, right? And the new capacity, the total capacity the total installed capacity, and the total on the new installed capacity, right? So for example, imagine that you want to consider, for example, how much of, for example, iron is, um, or no, better, steel is consumed for the construction of a wind power plant. So in this case, for example, in the in the input to new capacity, it would be possible to consider that, for example, I'm going to say whatever, you will need 1 kiloton of steel for, let's say, 1 gigawatt of, um, wind power plant, right? So in that case, you can try to account for this kind of resources when you are building a new technology. And then for total capacity is more the resources that you will need to, um, have one installed capacity. Like for example, let's say that, um, you have 2 gigawatts of installed capacity in terms of solar power plant, as of a solar power plant, and then you will need some kind of, not sure, any kind of, let's say, um, kind of material probably to, do the maintenance of those 2 gigawatts of solar power plant. So you will need like 1 unit of, that material for each gigawatt. So at the end, it's like the ratio would be 1 to 1 once again. So this kind of things. There are some exercises that we have also where we use this, for example, in other terms, for accounting for the number of jobs that are generated when we are building, or creating or constructing a technology, and also, for maintaining that technology. So for example, the input to new capacity would be something like the number of jobs for constructing, X capacity, and then total technology would be the number of jobs for running, that capacity, or for maintaining that capacity. So more or less, this is the kind of, let's say, usability for these two parameters. But for for this exercise, we are not going to use them. Then finally, let's remember once again, update the model. Here we have storage. We are not going to consider that. Also constraints. They are more, let's say, not advanced topic, but, and we are not going to cover this. Probably maybe in a future exercise we can try to check that. But basically here in constraints you can like create, um, customize or specific constraints for your model. Like for example, let's say that you want to reach 20% of renewable, so it would be possible to create a constraint here to represent that, to reach that objective. And finally, scenarios. We will come back to this later just to see how to include the two scenarios that we are, supposed to do for this case, right? Well, okay, once you have everything here in the home page, or sorry, in the configure model page, then we will proceed with the, inclusion of the different parameters, right? So in this case, we will start with, okay, before that, maybe one assumption important here is the discount rate. So here, if you go here to the fourth option, you have the data entry. So here you have the complete list of the different parameters. You can navigate through these just like scrolling down, but also if you don't want to do this, it's possible just to do a basic search. Here is not quite important because the discount rate as here. So this is the global one. Right now is in 5%. So we are going to change this by 0.09 to represent 9%. Please just remember to save the data here to save the changes. Then for the discount rates, the individual discount rates would be more or less equivalent to a hurdle rates. Once again, we will change this by 0.09. In case that you have data for considering these rates different from the global one, because you already know what is this kind of parameter for the different technologies in your country, your region, you can just work with different rates, right? So here, this is more or less similar to Excel. So for example, here I can copy this value using Control plus C, and then just move this and select everything using Shift Control um, right arrow, and then just Control left, Control V, and the numbers will be copied, right? As you can see here. Once again, save it. And yeah, so this would be like one of the essentials important. So change the discount rate. Then let's continue with the different parameters. So we'll start with um, the GR split. Here would be interesting. Okay, here once again is like you have it over there, so it's not quite important. Here you can see that we have the different time slices is equivalent to this table. So the assumption for this exercise is that all the time slices are going to have the same duration. So it's just like 0.25 representing 25% of the year. So here, once again, it's similar to Excel. You just need to copy this, go to the interface, select the first cell here or field, and then copy, Control plus V, then save it, and that's everything, right? One good strategy when you are handling data probably is that you can like create this Excel file to manage all the data, and then once you have more or less everything, you can go to the interface and try to add the data. However, also in terms of kind of advice, is always good if you're working, especially if you are trying to build bigger model. It's important to go step by step. So probably just to start with a small subsystem inside that model, and with just a few technologies, run it, proof that that it is working properly, and then add another part, then run it, and so on, so forth. Okay, just to verify that everything is going well, and that maybe to create everything right, all the whole skeleton of the model, then and then run it, and with many technologies and communities, then it will be more difficult to know where the problem or the issue is. Okay, the next parameter is specify annual demand. So here, okay, let's save it. Remember, if we save it later, before. So here, just specify, we can just search it. So here we have the specify annual demand. In this case, the final demand is going to be electricity 002. So is the value here. So we need to copy this. As you can see, it's like basically a linear increasing series. Go here, copy, save it. The next one is the specify demand profile. That is basically what is the percentage of this demand that is going to be consumed in each time slide. So here we can see that in the rainy season we consume around 45%, then 55% in the dry season, with different ratios or better proportions in the different time slices. Here again, we can copy this. Obviously, these values are maintained constant here, but if your model is different, they can have a different variation depending on how your model is. Here we have the specified demand profile here. So please take care with selecting the right commodity. We are working with electricity 002 as I mentioned before. So here you just need to copy this, right? you can verify that everything is filled. So we can save it. Let's continue. Then we have capital cost. Um, Another important thing, it's a minor detail, but please keep in mind that you create the technologies in the same order as I did, because in that way it's like, for example, if you go here to capital cost, you have capital cost here, so it's like you have this, the same order is the same here, so you just need to select everything and you can copy directly, right? Because otherwise, if you are creating the technologies in a different order, it's like you will need to like move just technology by technology, and guarantee that everything is fine, right? So good. Here we can change the values, save it. Next one is fixed cost. Um, Here we have it, right? Then just copy. This becomes more or less um, a repetitive activity, but let's say, as I mentioned, it's like part of the of the modeling work. Um, Also, when let's say that here I'm doing this like in a very mechanic way, but when you are doing this step by step, it's like it's important to check, for example, if the values are reasonable, if they are in the right place. So it's part of the work also to be careful on what you are doing. So here, let's say that this is more or less different. Notice that here the values are in a horizontal shape, but here they are vertical. This is not really a problem because we could do this like in a vertical way, but let's say that because they are just um, a few technologies and I remember the numbers, you can do this by hand as well, but also you could do something like just copy this. I would be like more or less put this in a horizontal way, then go here, copy, select the first one, and then copy this, right? So it's like we have the values there. Obviously, that you can also do it like one by one by hand. It depends on how you want to work it. Good. So once again, don't forget to save it. Always that you make a change on your model, please save that change, right? Here, good. Then we have capacity to activity that is very similar, right? So here the series will be horizontally. So look for capacity to activity unit. Here, put this here, put the values, save it. I'm not like explaining every parameter because probably you are more or less familiar with everything before starting with this, but once again, just like a kind reminder, in the read the docs link in the description of this video, you will find like everything around initial instructions to get familiar with MUIO and osmosis. Then we have the input activity ratio. Go here. We have it here. So in this case, as we know that only natural power plant, natural gas power plant and transmission, they are the unique ones with and let's say input fuel. They are the unique two technologies appearing here because for the other ones we know that they don't have anything. So here we can put the numbers, save it. There, the other thing is that when two parameters are sharing the same dimensions, like technology, commodity, mode operation, year, it's like they will also be available here in this drop down menu. So here we can just select the output and then we will have the values here. Basically by default, you probably know that we work with, sorry, we work with 1 as default value for the output. Obviously, here in the interface is 0 to avoid link everything, but probably when you are copying and pasting the values, they will be 1 for everything. Um, Good, perfect. So they are the input and output. Then we have capacity factor. So here we have capacity factor. In this case, we are just working with capacity factor for the power plant, so solar power plant. So here, please work with this slide bar in the on your right, and look for the spaces for solar, right? So take care of copying the values in the right place. So here, sorry, because this is moved. Notice that here we have this is only for solar technology, right? Just let me complete these values here that we're missing, right? So this is just for solar power plants, so you will need to copy this value just for these four, right? Then move here, take care to select the first one in the solar row, then copy the values, and notice that we are just affecting the solar part, right? For the rest of the technologies, we will work with the capacity factor, right? Remember, this is basically the um, production ratio in each time slice, depending on the nature of technology. We know that, for example, for solar at nights, uh, it is not available because we don't have sun at night, clearly. So here this is 0, and then in the day, this is the, let's say, average capacity factor. So around, for example, 31% of that installed capacity is available in the rainy season during the day. Okay, so save it, right? Then we have the availability factor. Um, this is more or less similar to the capacity factor, but it just consider the whole year, right? So it's like more or less the average availability in an annual basis, right? So this is the reason why um, we are using this for this dispatchable technology, that is the natural gas power plant, and also we use it for solar, but just to account for the time of the year where we can have this kind of plan maintenance. So it's necessary to disconnect the plan for different works. So we are like using this parameter to represent that times where the technology is not available, as the same name is indicating, right? So here we can use the availability factor, and here we can copy the values, right? Good. So then after that we have the upper limit, the model upper limit, that is basically, this is a representation of the reserves of natural gas, because it's just linked to the domestic natural gas production. So here, please take care also here that this is model period and not annual, right? So it's model period, and this is just going to be for mean gas, 7,500 petajoules. Save it. Then we have the residual capacity, that is the existing capacity. In this case, we are assuming that we have 1 gigawatt installed of natural gas power plant, and it's going to be constant until the end of the modeling horizon. We don't have any of solar power plant, and then we have equivalent value for transmission and distribution. Okay, good. So just copy the values, right? Then let's go here to residual, right? Let's copy the values, save it, and then finally the emission activity ratio, that is going to be just for the power natural power plant as I mentioned before, and then this will be the value here. Good. Then one final thing that I'm used to do is just here and update the model. It's probably not compulsory, but I like just to verify that everything is fine. Okay. Before adding the scenarios, I want to do this initial run with the baseline data. One additional thing that you can prove is basically in model diagram just to check that the connections are well. So notice that here is like an equivalent version of the reference energy system. So we have the two primary with natural gas, solar, transmission, and final demand, right? So it's basically this, right? So we have primary, natural, solar, connected to transmission, and finally supply and demand, right? The same is with the simple, right? So it's more or less, once again, a representation of the reference energy system. And then for view data, here you have like, you can analyze the different data for technology, for commodity, for emission. So here is more or less an a quicker way of checking data, especially when you want to verify data and you're working with many things and you know that probably one problem is with one specific technology. This is much easier to have a kind of a scan of what is happening with all the parameters, and maybe you are able to find out that something is not working with, let's say for example, the total mass capacity, so you need to change the value. So instead of going here and explore each parameter for each technology, you can like go technology by technology and check all the parameters. So it could be useful for that kind of activity. Then in run, to run the case, we just need to put a name for the case. So let's say that will be baseline case, right? Or baseline scenario. Then you can put a description if you want to. Click on create case. Here you will have this creation, initial creation. You can click here and validate inputs. Okay, we need to generate data file first. So after generating data file, you can also go here to cases, then click here in validate inputs, and then you will have a kind of a checklist of different important validations which which can help you with verifying that everything is well with your model initially, at least. So please, if you have any doubts, maybe in initial errors that could be more or less common, you can use this as maybe an initial diagnosis on what is happening. Okay. Then we have the data file created, so we can run model. Now it says that everything is fine. We can go to the results. So basically here in the results you have many options. I'm going to explain just a few. So for example, here you have the different variables or outputs of the model. Here it starts with accumulating new capacity, which for this case is not more or less very important. But for example, if we review the total capacity by technology, we can see that at the beginning of the period, we have some values regarding the capacity that we have, right? So let's remember that um, in this case, right, we start with 150 petajoules per year of extraction, and then also 50 petajoules of um, capacity for importation. That is in this file. If we go to parameters residual, notice here that is 100 for mean gas and for imports, right? Then the interesting thing is that then it decreases. So probably it's because the operational life. Good. No, it's here. 100. Just let me check. Oh, okay, no. Okay, here is a problem. Notice that here the value should be 150, but it was not outdated accordingly, right? So we can change this, just save this change, and we can use later. It is not going to affect the model um, in anything, right? But just let's do this kind of, imagine that you have an error, right? So like this case, right? So let's imagine the residual is wrong, right? So here we will update this, so you can save it, right? Then you go to run, you can select the file, they select the case, sorry, then out that case, generate file, and run the model again, right? And we are there, right? Then let's go to the results. Notice that now we don't have this kind of behavior in the accumulated new capacity either. So if we go to total capacity, notice that now is like 150. Notice that this capacity is enough until 2028. Then in 2029 is necessary to produce, or that is equivalent, right? Like to install more capacity of production and correspondingly to produce a little bit more in order to satisfy the increasing demand, right? This is the kind of analysis that you can do. Also, in terms of production, you can go here. Notice that here we can see that we have this per commodity, but you can also play with this that is more or less the same that as a pivot table. So here in columns we have commodity, but also we can have tech. So you can just click on select this and then move it here, right? And now you will have commodity and technology. If you want to deactivate, you just need to click here, and now the graph is in terms of just the technology. So here we can see that we are producing with natural gas, and basically with natural gas power plants until more or less 2032. Then in 2033 we have a very small penetration of solar in each year until 2035. You can also have the values here, right? So notice that you have the values in say visually or in a graph here. You can also change the kind of graph that you have, right? But it depends on what you want to do. Basically, it's going to be more or less always better to work with a column graph, right? But it depends on what you want to do. It's possible to do it, but just to say that here you have the graph, but also you can have the table here if you want to work with the values. Also important, but I will mention this later, but just to close this, to say that you can play with the different dimensions right here, depending on what is the kind of variable that you want. For example, another thing that you can explore here is the emissions that we will see later. So here notice that we are increasingly producing more electricity with natural gas, so correspondingly the levels of emissions are going to increase as well, right? Then the other thing that I want to say is that here in results, sorry, here in run, uh, when you have this baseline and it's already run, you have also these results in a CSV format, right? So everything that you have more or less here is here. So in case that you want to work as outside MUIO, just because probably you want to have better graphs or you want to do further analysis with some operations outside, you can download here, download results file, and you will have everything ready to work in a raw format, right? It's another thing that you can consider. Good. So now let's check the final part of this, that is basically how to work with the scenarios. So in this case, we will create two additional scenarios according to what we have here. So the first scenario is just the modification of the reserves. So imagine that at the end, let's say for example, the exploration campaigns in the country are not successful. So these reserves of natural gas, which previously were calculated on um, or better based on estimations of the future discoveries, um, are at the end not possible. So we will need to reduce this forecast of reserves, and now this is just 1,500 petajoules, right? So here, first step is to create two additional scenarios. So we add two more. One will be res, just to represent reserves scenario, right? And the second one will be EMI, let's say. So it will be like the emissions scenario. This is because the second scenario, then sorry, before of the model, then it's just because the third scenario is about to include an emissions limit of, let's say, a cap annually of not passing or surpassing 8,000 kilotons of CO2 emissions, right? So here we have the two scenarios. So in the first one, the parameter that we are interested in is the total technology, model periodicity upper limit. So we go here to upper limit, right? It's this one. This upper limit, we have the initial value for the baseline, that is 7,500. But in this case, we want to modify the value in the rest scenario. So please check that the rest scenario, in this case would be the rest scenario, reserve scenario. So click here in this part about the scenarios, then verify that the desired scenario is selected, and then open here, right? This is open scenario. Then after doing that, notice that like a duplicate of the parameter database is open. So here we would just need to modify the, let's say, desired values. So in this case, it's just for the mean natural gas, right? So in this case, it will be 1,500. So here we got the value. The other values, they are going to be the same. So we keep it as not applicable, and then just save it, right? So basically that is like the variation in the second scenario. So instead of having 7,500 petajoules of natural gas available now, we will see how the power sector behaves considering a reduced level of natural gas reserves, okay? Then let's run this model, this second scenario first. So we can go to run. We will create a new one. So let's call this reserves, right? Then here in scenarios, by default, all the constraints are selected. One important thing is that notice that here what we are doing is basically to override, right? Override one condition on top of the baseline scenario. So it's basically that the baseline scenario is going to be always this one, right? Although it's going to be this one, or is that here I cannot change it, or sorry, unselect it. So basically this is the baseline, right? So what we are doing is just to override, right? So here's like we are changing one value for the one in the desired scenario. So here by default everything is selected, but here we know that we just want the reserve scenario to be active. So here we save it. So here is basically the reserves is baseline plus the change in the reserves, right? Is basically that. Then we can create the scenario, then we can generate, and then we can run it, right? So it's there. Then we can go to results, and notice that here we have plotted the baseline one that was our previous run versus the new one that is about reserves. Notice that here the big difference is that now, because of the scarcity in the reserves, the penetration of solar power plant is higher, right? So it's more or less the main conclusion. Now let's check the other scenario, that is emissions. So here the parameter that we are affecting is the annual emission limit. So here the change is that instead of being unconstrained, that is 99999, in this case we will use 8,000, right? So we will use these values, then copy and paste it, and then save it. Sorry, it was a mistake. Notice that here, this is like for the baseline scenario, right? So let's come back to 999999. Sorry, let's do this baby in a better way. I don't want to make any mistakes. So let's consider it 9999. Sorry, it was my mistake. So let's copy this. Alright, so go here. Sorry, let's come back to the initial value, right? Now, once again, for the scenarios, please go to the top of the scenarios. In this case, this is not reserves, it's EMI, right? Open the scenario here, right? You have the values here, and then now we can do what we want to do, right? That is copy the values of 8,000, right? So here we can copy and paste it, save it, and now let's just update the model, run the same new scenario, emissions. In a scenarios, please, reserves, we are not to consider reserves now. So it's just going to be emissions, right? Save it, create the case, generate the data, and run the model. And now it's done, right? So here, results, and we have emissions here. So basically, notice that once again, because of the emissions constraint, we have more solar penetration, but in this case it's just like it's a little um, less than in the reserve scenario, right? This is because I can see the accumulating capacity, but it's also translated to what is happening with the production by technology. So here, once again, just let me put the tag here and select commodity, and notice that here you can see this in a better way. Obviously that here you can say that okay, but we are having like increasing trends, but it's not happening the same here. But it's just basically because here we are working with different levels. Let's say that to produce with natural gas you will need more natural gas than if you are using solar, right? Because you are not considering this. So just let me simplify this by in select is another thing you can do is like filter. So here we go to select, and let's say just what is happening with the production technologies, that would be natural gas and solar. So just um, once again just right click here in tech, then you will have this window pop up, and then you need to click on edit, select your desired technologies, okay, and notice that here you have the behavior of the demand, because the demand is constant for all the scenarios, so we should say the same for everything. And notice that here the difference is just like in the first scenario, in the baseline, we are producing mostly with natural gas. Then for emissions, after reaching the cap, right, so let's say that here in this part, so after producing 69.14 petajoules of electricity with natural gas, here is like the maximum level with the emission constraint. So after that it will keep constant, because of that constraint it's not possible to produce anymore, so the remainder is going to be produced with solar. So this is the behavior behind emissions. Then with reserves it's a little more complicated, because it's like you have the total amount of reserves for the whole period, so the model can decide that probably, depending especially of the cost of solar, is maybe cheaper to produce in 1 year than another. So notice that here the behavior is not too much linear like here, but let's say that it increases. Even here the increase is not too much. So for example, in 2030 and 2031 is like okay, the production keeps constant, and then it increases again, and then it has like an important decrease, and then it even at the end increases a little bit more. So let's say that here, because the model can play with the whole amount of reserves depending on which year you can produce, is going to be different, right? How do I know that all the reserves were used? It could be with this same production by technology. So this is just like a kind of also we can see emissions, but just to see that we are using all the emissions here, we can just select the mean gas here, right? So here it's just here, but notice that here, if we select for reserves, that would be these values. You can select these values, copy them, then just do this kind of verification. You can put the values here, so you have all the values here. If we add all these values, you can verify that the amount is basically, obviously we have some kind of rounding thing there, but the value is 1500, right? That is like the limit that we impose in the model, right? So this is kind of verification that you can do. So let's say that everything is working well with this. Then the other thing is, just I was mentioning, you can also analyze the total capacity. So total capacity by technology. So basically you can also remove here, for example, what is happening. Let's say that I'm not interested in seeing, but I'm just interested in seeing what is happening with the plants. So notice that here the capacity is less in the baseline scenario compared to the reserve one, but it's because, let's say that the capacity factor of solar power plant is smaller, so you will need more capacity to produce the same amount of energy compared to natural gas. So here, let's say that we have a kind of exponential increase in the capacity of solar. And then finally, with emissions, annual emission technology, notice that here we have the cap of 8,000, right? So it's like we increase our production until reaching the maximum level, and then it stays constant. And here we don't have any constraint, so it can produce even more than 8,000, but then because of the availability of reserves, it decreases. You can also compare these scenarios, for example, between this annual cap and also reserves, for example, here, and determine which scenario is even better in terms of whole emissions, like by adding all the emissions across the years, you can maybe check if maybe this measure is more effective in terms of reduction of emissions compared to this one. And obviously, one first thought is that the answer is yes, because here is like constant and here we are decreasing. So this portion, because this is more or less comparable, right? So what we have here and what we have here is more or less the same. But after, let's say for 2033 and beyond, this portion is like less emissions compared to the emissions scenario. This is the kind of analysis that you can do later when we are working with different scenarios, etc. So in general terms, this is everything. If you are interested in starting with creating an osmosis model in MUIO, this is more or less the process that you can follow. I hope that this video is useful for your purposes, and see you in the next opportunity. Thank you so much. Have a wonderful day.